Welcome to Lesson 5. This is the introduction to variables on both sides of the equation, and this is page 9. Our goal, I can solve an equation that contains variables on both sides of the equation. In this lesson, we'll work on bridging our prior knowledge to new concepts. So would you please start by solving the following two-step equations, and please show each step. You may pause this video and do that. Okay, let's analyze these equations. We start with a coefficient and a variable, a constant, and on the other side of the equation, there's just a constant. The second equation started with a constant on one side only, then it had a coefficient and a variable, and another constant. So that's what we've been used to working with. We've been trying to whittle down our term combining and our distributing so that we can create equations that look very similar to these. So that's what we're familiar with as of now. Let's go on. Let's also now look at something that we're familiar with. It asks us to simplify the following expressions by combining like terms. So you're going to notice this is an expression. There's no equal sign, so our answer will not be x equals a number. It will just be fewer terms. So please pause this video and would you simplify 3 and 4 by combining like terms. After we put together our terms or combine together our terms with our variable x and then the constants, this is the answer. And that was kind of hard to accept initially when we're just starting with this because it really doesn't look like an answer. We're expecting our answers to not look like an expression still. So now let's move on. The following equations below look very similar to the expressions above. So I'm noticing all these terms are the same as the terms here, and all of these terms are the same as the terms in number 4. However, 2 of the terms are on the opposite side of the equal sign. And because these are equations, we will work to solve them. Oh, we're going to get to find an answer that looks like an answer when we solve these. So far, we're familiar with equations that just have a constant, a number only, on one side of the equation. For instance, it is unfamiliar to see a term with a variable on this side when there's already a term with a variable on the opposite side. So today we will discuss methods to eliminate one of the terms with a variable, which adds an additional solving step. So would you please turn to the next page? When we are given equations that have variables on both sides of the equation, we want to mathematically get rid of an x term on one side of the equation. We do this by zeroing out the entire term, coefficient and variable, on one side of the equation. So for instance, if I had this, I'm just going to make up this particular equation. If I had some number and I was adding 4 to it, I would subtract 4 in order to get rid of it. However, if I had 4x, I can also get rid of that entire term by taking away 4x. Because we're working with equations that have terms with variables on both sides, how do we choose which variable we want to get rid of, or which term with the variable we want to get rid of? Well, generally, we try to choose the weakest term with the variable because this can often help us avoid a negative. By weakest, we're looking for the term that has the least value. That often will leave us with a positive coefficient, and that sometimes saves us from those tricky little signs. So let's start this and let's see what it looks like. We're going to build our wall, and even though we're used to dealing with the coefficient, trying to get rid of the coefficient first, this is the case where we take away a term with a variable first. So I have 2x, I don't want to see that, or 4x, I don't want to see that. I have to choose, and since 2x is the weaker or the least term, we're going to go ahead and try to get rid of that, and we mathematically get rid of that by taking the entire term away. For instance, if you had 2 apples and you took 2 apples away, you'd have no apples. But I do exactly the same thing on the other side. So this looks maybe a little bit uncomfortable when we first start this. If you deal with this side, we have positive 5, and that makes sense. We just drop that down. And now we need to think about this. If I had 4x and I took away 2x, just like we're combining terms, I would have 2x left, and also that coefficient plus 7 drops down. So this is now our new equation. But it'd be helpful if I made it an equation. So now we have what looks like a traditional two-step equation. And so we're going to continue our solving steps. We want to get rid of the constant. And we're going to try to get rid of this constant. Again, I'm going to start on the side that now has my variable on it. And we are going to take away 7 on both sides of the equation, leaving negative 2. And on this side, we have 2x. So we weren't able in this equation to completely avoid negative. However, we were able to avoid a negative coefficient. So we're going to go ahead and continue our solving step. We're going to divide by 2 on both sides, and our answer is negative 1 equals x. So that was the first method or way we could solve this equation. And we once again went after the weaker of the two terms that had a variable. So here's the same equation. So let's look at our second method. Alternately, we can choose to have the term with the variable kept on the left side. Often, students are more comfortable having the variable on the left side as opposed to the right side. So once again, when we have equations that have terms with variables on both sides, we want to eliminate one of those terms as our first step. So this time, I'm going to take away the 4x's. So I do not have any x terms on this side, on the right side. So I need to do exactly the same step. If I took away 4x on the right, I have to take 4x away on the left. And what happens this time is 2x minus 4x would be negative 2x. I'm going to drop down the constant of 5, so we didn't do anything with it, didn't eliminate it, and I'm going to drop down the constant of plus 7. I'm going to drop it down as positive 7. So now again, it's now a two-step solve from this point. So I'm going to traditionally do what we do. We eliminate the constant, and then I'm going to drop down the leftovers, so to speak. 7 minus 5 would be 2, and then our final solving step would be divide by negative 2 on both sides of the equation. So we will indeed get exactly the same answer. It's just that our x will be on the left side, and our answer, constant answer, will be on the right side. So you may have noticed that these equations take 3 steps. 1, to eliminate a term that has a variable on one of the sides, and the second is to take away a constant, and then to eliminate the coefficient. So there's 3 steps, and this is frequently asked. You have to start by eliminating one of the terms with a variable, and you do not, but I'm going to strongly encourage it. So for our purposes, when we have equations that have terms that have variables on both sides, I'm going to ask you for right now to go ahead and eliminate one of the terms that has a variable. I'd like you to go ahead and start. It doesn't matter which term you eliminate, but pause the video and go ahead and try to solve this from start to finish using 1A or 1B as a guide. All right, you may have started differently than I did. I chose to eliminate 4x by taking 4x away. You might have decided to eliminate 7x by taking 7x's away. So either way, this particular one kind of met both methods. This is the weaker term, and also my x term ended up on the left side. So if your equation doesn't look exactly like that, that's okay. But what is important is your equation at the end should say x equals -4 or -4 equals x, depending on which side you chose to eliminate. And right here, want to make sure that you spotted that minus sign and brought that down as a -9. So now let's go on to letter D. Go ahead and solve that on your own. And start the video when you're finished. So once again, I chose the weaker, the least value of the term with the x, and that's what the one I eliminated, which happened to leave my x's on the left side, my x terms on the left side. And again, if you started by adding 2x, that would be fine. Our final outcome, our final answer, though, however, should be exactly the same. It might just be written backwards. So it should be x equals -5, or if you started the other way, it'd be -5 equals x, which does indeed mean the same thing. So let's now look at the last set of equations. You're going to notice these look a little bit different. They only have a term with a variable on the left side, meaning there's not a constant. And what do you think would happen if I eliminated this term? Well, I don't want you to write this down. I just want to explore it right now. So if I decided I was going to eliminate this term, I'd take away 4x and I'd take away 4x's on both sides, leaving me with -2x minus 6. And then, if I had 4x's and I took 4x's away, I would have nothing. So I could start this way, but frankly, it's going to cost an extra step. It's going to mean I have an extra solving step. And that's okay. Let's just go ahead and finish it and then see if the answer would be the same if we do this a different way. So we would have -2x equals now 6. Divide by -2, divide by -2, and x equals -3. So we now know what the answer is. Let's explore another way to do it. So this time I would like you to write this down. So this time I'm going to go ahead and eliminate the term on the left-hand side. I'm going to take away 2x on both sides. And what's left over now is -6, because this eliminated, and 2x. So now I just have one more solving step to finish this up. I'm going to divide by 2 on both sides, and the answer is going to be -3 equals x. And that's exactly what we had last time. It was just x equals -3, which means the same thing. So when we did this the first time, when we eliminated 4x, it meant we had nothing here, but we still had 2 solving steps. By eliminating this term first, it just left one solving step, so we're able to save a little bit of time. So now let's go to our final equation. If I look at this, this is my weakest term. This is the one I'd like to eliminate. But if I do that, it's going to cost an extra solving step. So instead, I'm going to go ahead and eliminate the term on the left-hand side. That's going to save me a solving step. So this eliminates, leaving me with -10 on this side, and -2 minus 3, or a -2x combined with a -3x. Either way, it's going to give me a -5x. So I could have avoided the negatives by eliminating the -2x, but it would have cost me one more solving step. So it's really kind of your choice. So now I'm going to continue solving. I'm going to divide by -5 on both sides. A negative divided by a negative is a +2, and here these eliminated, leaving x. I hope you're starting to gain a little bit of a confidence about solving equations with variables on both sides. We'll of course practice this in our upcoming lessons. If you have a question, please ask. And there is a reference sheet in back now that lists all the different types of equations we've solved so far. So you can check the back of the packet and see if that's helpful. Thanks for listening. See you next lesson.